Hi everybody. Okay, today let's attack our problems from chapter 3. Today is June 4th. Oh, it's the 41st anniversary of when I got my first accounting job. So I asked you all to do problems 1 through 6 and also problem 8, okay? Now, whenever you take the first several, 1 through 5, I think. No, 1 through 4. You're likely to see one of these again, okay? I'll usually ask you, given all the elements of a stacked interest rate, and giving you a few pieces of information on parts that we do know, I'm going to ask you to solve for one that we do not know, and sometimes two, okay? It's not unusual for me to ask you to solve for two of the unknowns, but all the information you need to back into them or to add them up together will be there, okay? So you'll remember that the real risk-free rate is R star. We add an inflation premium that gives us the rate on a T-bill. We add an MRP, a maturity risk premium, and that gives us the rate on a long-term T bond. Okay, the only difference is payment for the risk that time brings with it. Then we add a default risk premium. That's not for the US government, obviously. That's for a high-quality corporate bond, okay? The best of the best, because even the best companies are not immune to default, okay? And finally, if there is any risk that a smaller company bond can be readily sold in an open market, then we also would want to be paid for liquidity. That's what the LP means, okay? So let's attack a couple of these things and see how it's done, okay? So the first one, pretty straightforward. The interest rate on a T bond is 10.7, and on a T bill is 5%. 10.7 versus 5%, okay? What is the maturity risk premium? All right, friends, the only thing separating those elements is the maturity risk premium. So if you know the rate on a T bond, which I told you is 10.7, and if I tell you what the rate is on a T bill, which I told you was 5%, I believe, right? What is the maturity risk premium? It has to be the difference between these two elements. Okay, therefore the MRP has to be equal to 5.7. And that's our answer. It's that easy, okay? All right, very good. Now let's go on. We'll rip right through these pretty quick, I think. But as always, if you do have questions, make sure you let me know, okay? What I'm going to do is, in each case, I'm just going to keep copying and pasting this thing right here. And we'll use it as a little reference. Let's go take a look at the next problem. It says, the interest rate on top quality corporate is 11%. Top quality corporate would be right here. Okay. What else? The maturity risk premium is 4% and T-bills are 5. Okay, so let's hang on to the T-bill for a moment. This is going to be the T-bill. That's going to be 5%. Okay. Now, what do we do next? It says, okay, we're trying to find the default risk premium. That's going to be this element. And we know what the MRP is. So we're first going to find out what the rate on a T bond is. And we do that by taking a T-bill plus the maturity risk premium. The maturity risk premium is 4%. So if I take 5% and add 4%, okay, I get 9, and therefore the difference is default risk premium has got to be equal to 11 minus 9, or 2%. Okay? All right. Next, problem number 3. All right, once again, let's copy this and paste it right here. Okay. The problem says, all right, the interest rate on a T bond is 9.5%. The maturity risk premium is 2. The real risk-free rate is 2.7. What is the inflation premium? Okay. All right, number 3. What we're going to do is we're going to take 9.5. That's a T bond. We're going to subtract 2%. Let's list down what we know. Okay, a T bond is 9.5%. That's going to go right here. Okay. What else do we know? We know that the real risk-free rate is 2%. I'm sorry, 2.7%. Write that down. Okay? All right, very good. So we are looking for IP, the inflation premium. So we know that we can take 9.5 and we can subtract 2.7, okay? And that's going to tell us what the rate on a T-bill is. All right, so let's do that first. I'm going to take 9.5 and subtract the risk-free rate, okay? And that number is 6.8%, okay? All right. So if I know that 6.8% is what a T-bill is paying, and if I know the real risk-free rate is 2.7, then all I have to do is subtract those two numbers. Okay, let me make sure I did that right. 9.5 minus 2. No, I messed something up there, didn't I? All right. On a T-bond, it's 9.5. The maturity risk premium is 2%. Okay. Hold on one second. Let me check my numbers. Okay, my apologies. I was called away for one moment there. Okay, we were saying a T-bond is 9.5%, and we know that the real risk-free rate is going to be 2.7%. Okay, let's back up. Let's do this slightly differently. Let's take the 9.5 and let's start by getting rid of the MRP. Okay, and we'll back in that way. All right, so let's try that again. To find a T-bill rate, I'm going to take 9.5%, and if I look back at the problem, it says my maturity risk premium is 2%. This way makes a little bit more sense. I get 7.5, that is the rate on a T-bill. Okay. Now, if I want to find the inflation premium, I know the rate on a T-bill is just the real risk-free rate plus the inflation premium, and I know the real risk-free rate is 2.7. Then I can say take 7.5 minus 2.7, and that's going to equal my inflation premium of, let's try that again, 7.5 minus 2.7, 4.8 is my answer. Okay? So my real risk-free rate is 2.7%. My inflation premium is 4.8, giving me a total of 7.5 for a T-bill. If I add the MRP another 2%, I would get 9.50. Okay, so again, when you solve these, sometimes you're adding, sometimes you are deducting. Okay, and we'll do one more of these things. Let's paste and see what we've got now. And let me save this for us before we go any further. Okay. All right, number 4 says you're investing in a T-bond. You're not sure what rate of interest it would pay. The real risk-free rate is 1%, and inflation is expected to be 1.5%. Let's stop right there. 1 and 1.5. This time we're adding. Okay? Okay, very good. The default risk premium on top quality corporates is 3.5. The maturity risk premium is 2.5. All right, I detest trick questions, but this one almost comes a little bit close, and for that I apologize. But hopefully this jumps right out at you, because you know that we're talking about T-bonds. Do we care about the default risk premium? No, not unless I'm starting with the top quality corporate and backing in, okay? So watch out for anything that's extraneous. Here's the key piece of information you need right here. The maturity risk premium is 2.5, okay? So I'm just going to note that this is the IP. I'm going to note the MRP, which I've given to you. The maturity risk premium is 2.5, okay? Okay, so the total of those three should be what the corporate bond would pay. After all, a corporate bond, I'm sorry, not a corporate bond, a treasury bond, okay? The rate that a treasury bond will pay only has 3 elements. It does not have a default risk. So we can totally ignore these two right here. So I'm going to stop right here and say my real risk-free rate plus my inflation premium plus my maturity risk premium will give me the answer for I keep saying corporate, I'm so sorry, a UST bond, the answer is 5%. Okay? This is all a matter of adding. All the base level data was there for you. Okay? So I hope you've got a good flavor for these things. Again, it's possible I may give you a couple of elements. I may give you a corporate bond. I may give you a T-bill rate, okay, whatever, and ask you to find for one or two unknowns. All of the information to find the answer has got to be there. Okay? Problem number 5 says, let's go take a peek. All right, the Federal Reserve announces that M2 is 12.5 trillion, okay? You find that M1 is 2.8 trillion, and then I tell you that if traveler's checks, small CDs, and money market funds are 1.1 trillion, all right, then what is the number of savings deposits? Okay, what you do is you flip over to the page, it might have been somewhere around page 49 or 50, where I tell you all of the elements of M1 and M2, and that's going to allow you to solve this. Okay, let's go solve it. All right, first of all, M1, and M2, okay, let's identify those first, M1 and M2. And I want to do this in trillions of dollars, okay? You can do it in billions if you wish, but let's keep our numbers smaller. I told you that M2 is 12.5 trillion. I'm just making these numbers up. Okay, so we're trying to back into one of the elements that separates M2 and M1. So let's deduct M1 because we know everything that's in M1 is also in M2. Okay, I told you that M1 is 2.8 trillion. All right, so this is all going to be denoted, and I'll do this for your edification, all in trillions of dollars. Okay? All right. So the differences that make up M2 over and above M1 are going to total 9.7 trillion. Okay. Now, we say to ourselves at this point, okay, what is in M2 that is not in M1? And we'll deduct that as well. Okay. I know that I deduct small CDs, and I know that I deduct money market funds, okay? Small CDs and retail money market funds, okay? I told you that the total of both of those elements is 1.1 trillion, okay? Less small CDs and retail money funds. Okay, that's 1.1 trillion. Okay, let's do another subtotal. Hang on, there we are, I lost my place there. All right, bear with me. Okay, I take 9.7, the total of all differences between M1 and M2, and I subtract small CDs and retail money funds. That leaves behind savings accounts. Okay? The differences between M1 and M2 are these three items. I gave you the total of the first two, so by deduction we know that the answer has to be 8.6. All right, now let's go back. I mentioned that traveler's checks are 4.1 billion. Do we use it? We don't have to use it. Why is that? It's because traveler's checks are included in both M1 and M2. So you don't need to deduct that from the differences between M1 and M2 of the 9.7 trillion, okay? There are three elements that separate them. I gave you two, pull them out, and you've got the third one that we were trying to solve for. Okay, I hope you found that, that handy for you. All right, problem number 6 comes next. 2 more to go. My typing is atrocious today. I ask you to bear with me, please. Problem number 6 says, okay, using the formula that I gave you, the bracketing formula in the book, I think it's somewhere around page 52, and I did an example like this for you in one of my lectures. I want you to assume that you have a bank that has total reserves of 115 million, and I want you to tell me how much their required reserve is. While we're at it, let's figure out how much they can lend as well. So the total reserves are $115 million. Okay, so that's our stop point. That is our baseline. That's a big number. Bear with me. There it is. All right, let's get rid of the pennies, and that'll make our lives a little easier. Okay, those are our total reserves. All right, so now we know that using the formula in the book, the first 12.4 million, okay, is not going to have any reserves at all. Okay, that's free money. The bank can loan it all out. Okay, from 12.4 up to 79.5 million. Okay, the factor is 3%. All right, so let's figure out what that is. I'm going to take 79,500,000. I'm going to subtract the amount we've already accounted for, the free money, 12,400,000. And I multiply that number by 0.03, that's 3%. So I've got to put at least another $2 million away, or I should say $2 million away, not another, in my vault or a deposit with the Federal Reserve. I cannot loan it out. Okay? And finally, anything greater than 79.5 million, all right, is going to be figured at 10%. Okay? All right, very good. We've accounted for the first 79.5 million. So I'm going to take how much we do have, 115, minus how much we've accounted for already in the 0 bracket and the 3% bracket. And I'm going to multiply that by 0.1. And that means I've got to put away another $3.5 million, $3.55 million. Okay? So therefore, my required reserve is going to be the sum of those numbers. Just like that. That is my answer. That's what I asked you to find. Now, just for grins, I'm going to say how much can the bank lend? Well, simply put, that's going to be their total reserves minus how much they're required to hold. Right? So they've got 115. They're required to hold that amount right there. Okay. So let's make that no decimal places. And that means that this bank is going to be able to lend out. And my time is up. Hold on, please. They may lend 115 minus the vault cash. They can loan out $109,437,000. Okay, $109,437,000. All right, very quickly, let's see if we can get through our final number here. Problem number 8. I didn't ask you to do number 7. Let's see what it says. Problem number 8 says, using the deposit expansion effect, we're going to use a flat 7%. Remember, the bracketing we just did, I will tell you, use the bracketing. If I want to keep your math easy and just use a flat percent like when we do deposit expansion, I will tell you, okay? So it's 5 million that's being introduced by the Federal Reserve into our money supply, and we have a flat required reserve that the banks must hold of 7%, all banks. All right, so that's 5 million in new cash and a flat reserve requirement of 7%. I gave you the formula several pages back. It's around page 56. The formula is to take the amount of new money minus the initial, the very first bank's required reserve. Take that result and divide it by the required reserve percent, and that's your answer. Okay? So, in this case, I would take 5 million. Okay? I'm going to take 7% of that. That's going to be $350,000, if my mental math is correct. And I divide that by 0.07, my required reserve. Okay, so let's see what we get. All right, I'm going to take 5 million minus 350,000. I will expect you to know how to do this, friends, for our quiz. And the answer is, okay, 66,428,571. That's the amount of new money in our money supply because the Federal Reserve injected $5 million. It explodes through the deposit expansion effect into almost $67 million. Please know how to do that for me, okay? I will save that, and I will be back later today, actually, with the start of my lectures, video lectures on Chapter 4 and its Appendix 4A. Enjoy the rest of your Sunday, please.